Hey, how's it going? Okay, Leetcode 1605. Find valid matrix given row and column sums. You're given two arrays, row sum and column sum of negative integers. Row sum I is the sum of elements of the ith row, and column sum j is the sum of the elements of the jth column of the 2D matrix. In other words, you do not know the elements of the matrix, but you do know the sums of each row and column. Find any matrix of non-negative integers of size row sum length x col sum length that satisfies the row sum and col sum requirements. Return a 2D array representing any matrix that fulfills the requirements. It's guaranteed that at least one matrix fulfills the requirements exists. Now, this isn't the first time I tried to record this. The first time I misread the problem and I was confused. I needed to take a few minutes to think about it. I'm really hoping that a naive solution will work, because if this is a quote-unquote difficult problem where filling in rows is going to screw you up later on, then all of a sudden there's like a, not literally infinite, but like a computationally difficult number of combinations to try. So I'm going to try to implement a naive solution, and hopefully that works. And if it doesn't work, then I'm going to look at a solution and hopefully learn something. So let's see here. Okay, so rows to fit. That's a little bit verbose. List of enumerate row sum. And then columns to fill is list of enumerate of col sum. All right. Print rf, print cf. Okay, let's take a look. Okay. Now, result is going to be equal to, let's see, the inner one. These are all 2. 2, 2, 3, 3. Okay, I assume this is 0 for I in range. Length col sum, and for j in range length row sum. That would make sense that a row would be the outside one. And then we will return result. So I want to look at this. Enumerate. Oh my God. Okay, so 0318, 0318. List of, yeah. We want j comma I for I comma j in enumerate, and then column is going to be, I want the counts first. All right, now the sum of the things in the rows, the sum of the things in the columns. I'm hoping that I can naively place these, like I said before. If I can't, I don't know how to do this problem. It's just too computationally expensive. If I have to try like every single combination, that's just going to be insane very quickly. So what we're going to do is while rf. Okay. Now we are going to say count rows, position row equals rf.pop, like that, right? And then count column position column equals CF dot pop. Like that. All right. Now we are going to say toPlace equals minimum of count row and count column. And if toPlace, that is, if it isn't 0, then we're going to do something, and then whatever is left, CO of R minus equals toPlace, because we placed it, and then CO of C is toPlace, and then if CO of R, then we're going to put it back in rp dot append CO underscore R, comma POR, not PRR. And then obviously the same for the column. So we only put it back if it's non-zero. That makes sense to me. And this should terminate, because we should always be doing non-zeros. Okay. Now here we want to assert that RF is none, and assert that CF is none. So let's see if that works. RP is not defined. It is supposed to be RF. And this is supposed to be CF. Okay, so it is terminating, and it is clearing everything out, and it's not running an infinite loop, which is exactly what we wanted. Now, this is trivial. This is the step where we assume that the naive solution with, you know, no funny business, no backtracking is going to work. So res, wait, which one goes first? The row goes first. So row column plus equals place, just like that. And it worked. Okay. Like I said, if one placement was going to screw up a future placement, then that would have been a problem. Oh, interesting. Haha. Okay. Oh. Pop from empty list. That should not be happening. If J. Come on, self. Okay. That passes all of them, including the all zeros. And this means that we got the dimensions correct. So I think that should work. All right, sweet. Okay, see ya.